Hi, welcome to HacktivityConf. We're going to talk about service mesh to service mesh, a journey around service meshes, and in particular looking at Istio and LinkerD. We'll see a live demo of each of those. Let's dive in. So here's the part where I tell you I'm definitely going to post my slides on my site tonight. You're going to go look on my site tonight, tomorrow, next week, next month. In about 3 months, you're going to get tired of waiting. You're going to email me. In about 6 months, I'll reply and say, no, I'm definitely going to post them on my site tonight. And I'll never post them at all. I've been in this spot and I hate it too, which is why you can go to robrich.org right now and you can pull up the slides. Let's go to robrich.org. We'll click on presentations. And here is service mesh to service mesh. You can see the slides right here. While we're here on robrich.org, let's click on About Me and we'll look at this page. I'm a Microsoft MVP. I'm a friend of Redgate. AZ Give Camp is wonderful. AZ Give Camp brings volunteer developers together with charities who otherwise couldn't afford software services. We start building software for them Friday after work. Sunday afternoon, we deliver that completed software back to the charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ Give Camp. It is a lot of fun. Or if you'd like a Give Camp in your area, hit me up by email or Twitter, and let's get philanthropy installed in your area as well. SQL Server Source Control Basics, that was a lot of fun, minus Chapter 8. I was on the Gulp core contributor team in version 2 and version 3. One of the things that I'm particularly proud of is I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woohoo! So there's my claim to fame. So let's dig into service mesh to service mesh. When we look at a service mesh, we talked about this guy. When we look at a service mesh, imagine when you were learning how to drive. Do you remember the feeling of that open road, the feeling of getting to control a machine, going fast, not getting caught going fast? Imagine the empty road in a country town. How much fun that would be to drive. Well, over time, lots of people may come into town, the town may grow up, and we end up with traffic. Well, now I'm not really going as fast as I want to. There aren't any signs or control stations. It just gets to be a mess. I'm not getting to where I want to be as efficiently as possible. So how do we solve this? Well, in time, we'll probably get out one of these. The officer's standing at the edge of town. He's going to go grab all of the people who are speeding. And ultimately, we're now able to move consistently through town. Well, we're moving consistently, but we're not moving efficiently. We've rewarded conformity over expedience. What would be better is if we could do something like this. If we had a mechanism where the cars could communicate with each other and prioritize traffic based on urgency or based on priority or just communicating so that we could all get there as quickly and as efficiently as we needed to. Now, this doesn't say that one car going faster or slower is better or worse, but rather that the cars can communicate together to make sure that everyone gets as fast or as slow as they need to get to their destination efficiently. We'll use this metaphor as we look at service meshes and compare that to the mechanisms around API gateways and other technology. What is a service mesh? Let's look at what is a service mesh. Let's look at some of the some of the features around service meshes. Let's compare service meshes to API gateways. Let's look at common service meshes. We'll look at Istio and LinkerD today. And then let's do a live demo of both Istio and LinkerD. That will be really fun. And then ultimately we'll talk about best practices. When should I use a service mesh? When should I not use a service mesh? Come join us. So what is a service mesh? Well, a service mesh manages network traffic between services in a graceful and scalable way. We could think of a service mesh as the answer to, how do I observe, control, or secure communication between microservices? we're inside of a Kubernetes cluster or another containerized cluster. We have all of our microservices, and we want to control, observe, or secure that traffic between those services. Well, how did we get here? So, observe, control, and secure. We'll dig into that quite a bit as we go. Observe, control, and secure. That's really what a service mesh does. Observe. It can watch traffic as it moves between microservices. It can see when one service calls another service, and it can see when services shouldn't call other services. Control. Now that I've identified which services call which other services, we can create policies around that to make sure that some services are able to call other services and some services are blocked from calling other services. We don't want a rogue service starting up and just calling out to the everything. Observe, control, secure. We'll do mutual TLS between our microservices. Now, the cool thing about doing this inside of a service mesh is that our code doesn't need to change to be able to communicate securely across the service mesh. We'll have mechanisms in here for mutual TLS, for trust chains. The service mesh can be a certificate authority, or we can lean on a certificate authority from an outside source. We'll communicate securely and efficiently. Observe, control, secure. That's what a service mesh is. So how did we get here? On the left, we have a mechanism of monolithic application. On the right, we have microservices. On the left, we had this monolithic application because deployment was hard. It was difficult for us to be able to push things to production, so we did it really infrequently. We would bundle as much as we could into that one thing, and we would push it to production, and then we'd be done. The hard part is over. As we got better at deployment, and in particular at containers, we moved to microservices like the service on the right. Now, each of these microservices accomplishes a specific task, and we can upgrade each one when it's necessary, or replace a microservice with a microservice that functions better here. We moved from monolithic applications to microservices because deployment was no longer hard, and now we have a whole lot more options. We can scale each service independently, we can communicate differently, but now each microservice is kind of public. Maybe not completely public, but in a monolithic application, all of our private internal methods were internal. They weren't exposed outside of our executable. In microservices, each one of our private methods has a web address. It might be an internal web address, but it's a web address, and anything could call it. And that's the problem that we're setting out to serve with a service mesh. It's starting to observe, control, and secure that communication between our internal services within our application. As we talk about securing communication, we'll talk about north-south traffic and east-west traffic. Just to kind of level set here, north-south traffic is traffic into or out of our containerized cluster. East-west traffic represents traffic going between our microservices. So for example, in this diagram here on the right, a user is on top, our database is on the bottom, so north-south traffic will go into our cluster or out of our cluster, and east-west traffic will go between our microservices. Just some cool terminology. What's really cool is that a service mesh allows us to control both north-south traffic into and out of our cluster, and also east-west traffic between services. So what came before? Well, we got to this point where all of our private services had IP addresses, and that was interesting, but now what? We created this API gateway. An API gateway is this boundary fence around our cluster. For any traffic coming into our cluster, it has to check in with the API gateway to make sure that it's allowed to proceed. If it has the right credentials, if it has the right keys, if it's running on the right ports, then the traffic can come in. Now it is just a boundary around our cluster, so it's able to control north-south traffic really easily. But it's not able to control east-west traffic. Now we see in this diagram that we have microservices calling other microservices. That's perfect. That's what we want. But the microservices are also reaching into somebody else's data source. We don't want that. But the API gateway, being this boundary fence around our cluster, has no visibility into that. The API gateway is merely the boundary around the cluster. That traffic cop on the edge of town, he couldn't patrol the content within town. His task was only to filter the traffic coming into town. The north-south traffic coming into our cluster. The east-west traffic between microservices, we can't manage that with an API gateway. And that's where we reach for a service mesh. So how does a service mesh work? At its core principle, a service mesh will typically deploy a sidecar within each pod. So in this case, service A wants to call service B. Service A is a container deployed in this pod together with a sidecar container, an Envoy proxy. Service B is also deployed with a sidecar proxy. So service A wants to reach out to service B. Without a service mesh, service A would just directly connect to service B. With a service mesh, service A is going to reach out to service A's Envoy proxy. Now the Envoy proxy is going to go check in with the control plane for the service mesh. Is service A allowed to connect to service B? If so, then the control plane will give service A the details of how to connect to service B, and it'll open a mutually TLS encrypted connection. Service A's proxy then communicates with service B's proxy, and service B proxy again checks in with the control plane. Is service A allowed to call me? In this case, the control plane is going to say yes, and service B is going to service B's proxy is going to forward the traffic on to service B. Service B will reply to the proxy. The traffic flows across that mutually encrypted tunnel back to service A's proxy and back to service A. The cool part is the pod boundary, that network boundary, is the only place where service A and service A proxy communicate. Everything outside the pod boundary is secured with mutual TLS. That's a service mesh. Service A communicates with service A's proxy. Service A's proxy checks in with the service mesh control plane, communicates to service B's proxy. Service B's proxy forwards it on to service B. Now we can switch out the implementation details. Perhaps service A is ingress into the cluster, or perhaps service B is outside of the cluster. So in this case, we'll have traffic coming in to the cluster. It will still check in with that control plane, and if allowed, it will communicate securely with the microservice in our cluster. Or for traffic leaving the cluster, service A's Envoy proxy will check in with the control plane, and only if allowed to communicate outside the cluster will it create that encrypted tunnel outside the cluster to service B. This is kind of the principle around service mesh, and this is that magical piece. We're standing in between the communication between all the services. Well, because we're standing in between the traffic here, we can do some really, really interesting things. We're going to start with observe, secure, and control, but let's dig in deeper. Observe, control, and secure. Since we're proxying all the traffic, we can observe all the communication between all of our services. Now this is interesting. We don't just get what the developer thought was happening, we get what's actually happening on the wire. Now we can create access policies. We can control that traffic. Is service A allowed to talk to service B? Or is service A rogue service that just got spun up? We can create these access policies so that only the traffic that we want flows in the directions that we want within our cluster. And then mutual TLS, security. We're creating this mutual TLS with a trust chain without impacting the code in our cluster. We don't need to change our application to be able to speak securely between our services. That's really powerful. Observe, control, secure. But let's not stop there. Because we're standing in between all of the communication in our service, we can step up a level as well. Let's map out the network topology. Now this isn't what the developer thought would happen in our cluster. This is what's actually happening in our cluster. Am I talking to the configuration service? If I'm not, Maybe those hard-coded debug values accidentally got checked in. We can check our network topology and make sure it is what we expect. Service health. Because we're standing in between all of the services, is this service timing out? Is it returning 500 errors? Is it taking too long to do a request? We can collect all of these metrics around a particular service and understand if it's healthy. Is it behaving normally? Is it behaving abnormally? Let's take all of that content and set it in the log. That log will allow us to collect all these metrics and to be able to do really interesting things with them. Because we're standing between the service, we can do lots of cool things around the traffic in our cluster. Let's level up again. So now let's start talking about traffic shaping. As we're creating these control policies, we don't just want to block traffic, but what if we create an A/B test? What if we take a new version and direct, 5% of the traffic, 10% of the traffic towards this new service and see how it goes? Or do an A/B test between two different versions and see if we can learn more about how our customers behave and optimize our site to create really elegant experiences. Or let's create a beta channel or a canary release and point those users who have opted in to that particular service. Circuit breakers are really powerful. Imagine a service is struggling. Well, if the service is struggling, we need to give it a break. If the service goes down, the first thing all the clients probably do is retry. So now that struggling service that was overloaded, that just went down, now it's starting to come back up, and suddenly it's flooded with requests. And so the first thing it does is, go down again. And so we'll have this kind of spike up and down, where the moment the service gets a little bit of its feet under it again, it falls over again with all of that traffic. Instead, let's trip the circuit breaker. Like circuit breakers in electricity, this circuit breaker is there to protect the equipment behind it. Rather than blowing the electronics in our device, we'll blow the fuse in our circuit breaker so that we can protect those electronics. Reset the circuit breaker, and now we can try again. Similarly, when the service is unhealthy, the circuit breaker trips, and now the circuit breaker can tell calling applications, this isn't going to work. Take another path. Perhaps it's a recommendation service, and we can still let the user check out. We just won't show them related products. We haven't given them a poorer, inferior experience. We've just hidden some of the lesser features in our site. Once that service comes back up and it's healthy, the circuit breaker has validated that the system is live, then we can flow traffic back to it, and that can happen automatically. We don't need to wait for a human to go reset the circuit breaker. In Service Mesh, the circuit breaker can reset itself when it's ready. All of these features are available in Service Mesh because we're standing between all of the communication in all our systems. Ultimately, we're logging all of this content, and we can start to visualize that in some really elegant dashboards. On the left is a Grafana dashboard where we see metrics around our service. On the right is a network topology diagram where we can see how services call each other. These kind of dashboards can give us great insight into our services and help us understand how our services are doing. We talked about preventing unexpected traffic patterns. Let's dig in again. Because a service mesh is standing between all of the things, we can see that in this case, our microservices are calling each other's data sources. We don't want to allow that. Let's create a traffic policy that blocks them from communicating with data sources that are not their own. Yeah, we'll probably need to re-architect our application to do that, but we're able to discover this, we're able to control this, and affect some real change, see some status updates in our cluster as we make these changes. A service mesh empowers us to have this visibility and this control into our service architecture. So what's some example service meshes? We could look at Istio and LinkerD. We could look at Console. We could look at Open Service Mesh. Each of these service meshes has features and benefits, and we could start to talk about, well, which one's faster, which one has the most features. And they all leapfrog each other. So for the most part, if you wait a minute, the other service mesh will have that feature too. So rather than comparing their features or their cost or their complexity, let's instead compare their methodology. Take a look at how these things are built and what they value. At that point, we can choose the methodology that best matches our needs, and that'll lead us to the correct service mesh. So for example, LinkerD. LinkerD focuses on simplicity, in particular, simplicity of getting started. It has the bare minimum features, they work really well together, and they're available out of the box really quickly. But if you want more complexity than that, more features, you'll pull in third-party packages that will do that. LinkerD is really good at crafting their own little pieces, and they work really well. They're contributing a lot to the Rust networking stack because they're building out LinkerD in Rust. That's really powerful. By comparison, Istio focuses on kind of having that kitchen sink experience. They install all the things, and you can turn them on and turn them off with flags, profile flag. Istio also bundles a lot of best-in-breed products into the service mesh. So you'll get a Grafana dashboard over the top of Prometheus sinks. All of this other open source software is bundled with Istio as well. So you'll get the best of breed baked in, but it is a bulkier install. You can turn features on and off as you need to, and that's really cool. So let's dig into a demo. We'll start out with a demo of LinkerD. We'll also look at a demo of Istio. So I have here a LinkerD cluster. Or rather, I have here a Kubernetes cluster that is, for the most part, empty. Let's spin up LinkerD. As we get started with LinkerD, LinkerD's getting started page is really elegant. You start out by installing the CTL. I've already, the command line, CLI rather. I've already done this. You put it in your path. I've done this as well. And next up, let's validate our cluster. LinkerD check -- pre. This will go through our cluster and validate that it's ready for Kubernetes. Does it have, or ready for LinkerD? Does it have all of the things set up? Is Kubernetes functioning correctly? In this case, yes. LinkerD install pipe it to kubectl apply -f-, and it'll pull in all of the resources associated with LinkerD. This install experience is really elegant. It just pulls it all in, and it just works. LinkerD check. We did -- pre before to say, let's go see if our cluster is ready. Now without the pre, we're going to go validate the LinkerD setup. And in particular, it will wait for those things to spin up as it needs to. And that's really cool. Is it ready? Go, 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 go. It's still spinning up. I love watching these things spin up, and I love how it checks to see that everything is running correctly. It does take it a minute to spin up, especially when my machine is doing lots of other things. But there we go. LinkerD is ready. kubectl -n LinkerD get all, LinkerD get all, and we will see all of the resources that LinkerD spun up. The deployments, the services, the pods, and there's other things. There's a cron job, that's pretty cool. LinkerD dashboard. Now the LinkerD dashboard is really cool. Let's dig into the LinkerD namespace, and we'll get to see all of the pods available in this namespace. Here's all those pods, their uptime, and we can get at a Grafana dashboard for each one. Let's take a look at, I don't know, this one. here's that Grafana dashboard explaining the service health for this particular service. Now, obviously, it's been up for, a second, so there isn't a whole lot of descriptive content. But that was really fast to spin up. That was really, really cool. Now, I'd invite you to come to LinkerD Getting Started, and there's a great way to walk through the dashboard and walk through a demo app. But for the sake of time, let's show Istio. Istio has a similar experience of getting started, where you start by downloading the Istio CLI, and I've already done that. Install Istio, set profile equals demo, and set the namespace default Istio injection enabled. We're tagging a particular namespace. We can do this in LinkerD as well. And by tagging that namespace, the Istio control plane knows that any pods that get scheduled into that namespace should have that proxy, the Envoy proxy, installed as a sidecar within it. And so now, as we start to deploy our application, we can just deploy it, and all of those sidecars will get pulled into place. I've already installed this book info sample application, and this works out really well. We have a product page. It will reach out to this service to get the product details. And then we also have this review service. In version 1, we have no stars. In version 2, we have black stars. And in version 3, we have red stars. And those will actually call out to this other service to get the rating. Now we want to experiment between version 1, version 2, and version 3, and so we'll see the stars either coming or going, depending on what version of the application we're running. I've got the application spun up right here, and in this case we're on version 2. Let's hit refresh, and now we're on version 1. We don't have those stars anymore. Let's take a look at, in Istio, how we would flip between them. Here's that Istio virtual service. And this virtual service says, I would like to point all of the traffic to version 1. That's what we've got going right now, and all of our traffic is indeed moving to version 1. Let's come back to the thing, kubectl config use context Istio demo. Okay, so now that we're in Istio, let's go move the traffic. So it's all on version 1 right now. Let's say we'd like, I don't know, let's put 80% of our traffic on version 1 and 20% of our traffic on version 2. kubectl apply -f virtual service reviews 80/20. Okay. Now that we've reconfigured that virtual service, if we come here, the majority of the time we won't get reviews, but every so often we will get the reviews and we'll start to see those stars. That's really cool. We did that live traffic shaping. Okay, so we validated that version 2 works. Let's flip completely over to version 2. Here in this one, it's only going to version 2. kubectl apply reviews v2, and now we will only get version 2. That's perfect. Well, now we want to do some testing. For those people who dig into the Canary channel, the beta channel, we want to be able to give them version 3, but for those people who don't, we'll give them version 2. So I think that actually might be backwards. So we're unauthenticated and we're getting version 2. Let's sign in, and we'll sign in with username Jason. Now we're signed in as Jason, and now we will get, oh, I expected that to be version 3. Oh, we haven't applied it yet. Let's apply it. kubectl apply -f virtual service reviews Jason. Okay, now we've got it. So now that we're Jason, we see version 2. If we log out, now we'll see version 3. That's really cool. We are able to grab a header and route traffic to different places based on that header. Okay, so maybe let's do an experiment. Let's split half the traffic between version 2 and half the traffic between version 3. kubectl apply reviews v2 v3. Okay, half the time we've got version 2, half the time we have version 3. And now we're able to test these two. Which one helps our users be most effective? I think version 2 is working version 3 is working pretty well. So let's flip everything to version 3. kubectl apply v3. There we go. Now everything is moved to version 3 and we will always get version 3. We saw how easy it was to configure Istio to be able to route traffic in interesting ways. We saw how fast it was to get LinkerD spun up. Console and Open Service Mesh are also great service meshes in being able to do interesting things. So let's take a tour through what we saw with service meshes. We're able to monitor, log, and do monitoring, logging, and service health, observe, control, secure. Taking a step up, we can do intelligent routing, where we can start to route traffic based on maybe A/B tests, or maybe circuit breakers, or maybe beta channels. Taking a step up again, we can now take a look at the network topology, the logging, the details around our system in what's actually happening, not just what we assume is happening based on the way the developer has explained it to us. If a service is misbehaving, we can route traffic around it. That's perfect. Zach Butcher wrote the book on Istio, and he says, if it doesn't have a control plane, it ain't a service mesh. I completely agree. And to that end, there is an implementation cost with the service mesh. We have a regular Kubernetes cluster here on the left, and we're adding to it all of the pieces of the service mesh on the right. In a Kubernetes cluster, we have the kube proxy, we have etcd, we have the controller manager. With the service mesh, we have the service mesh's control plane, the piece that does spinning up certificates, the piece that validates the routing rules. With a Kubernetes cluster, we have the pods, the containers that are running our particular workload. With the service mesh, we have all those sidecar proxy containers. In truth, we'll probably end up with about double the number of containers by choosing to include a service mesh. Now, maybe your workload that spins up a Java application or is doing intensive GPU calculations is bigger than the calculations involved in creating creating trusted certificates or connecting to different services. But we may expect maybe 1.5 to 2 times the workload running in our cluster as we implement a service mesh. Now that can require us to create a bigger, more expensive cluster to run a service mesh. Now that's okay, but understand that there are costs involved in building a service mesh. We don't just get this for free. If those costs are worth it for the benefits that you need, then a service mesh can be ideal. But don't just pull it out just because it's available. Service mesh is not the checkbox. Towards the benefits of service mesh, if I need that to observe, control, and secure my cluster, a service mesh is perfect. If I want to do that traffic shaping, if I need to validate access policies, or if I need security between my microservices, then a service mesh is perfect. Some great rules of thumb here. Use a service mesh if you're running trusted workloads like PKI or PCI. Use a service mesh if you're running untrusted workloads together with your expected workloads. You don't want the untrusted workloads to be able to get into your normal work, and you don't want your normal work to spill into the extremely sensitive information. And so you can create a service mesh boundary between those. If you're running multi-tenant workloads, Now, generally, we lean on Kubernetes namespaces for this, but Kubernetes namespaces are an organizational boundary, not a security boundary. And so by creating namespaces, we're not securing the tenants between themselves. A service mesh can enforce that boundary in namespaces. If we need security in depth, then service mesh can be great. Or if we need that advanced routing like AB routing or a beta channel, then a service mesh can be great. If you have these needs, then definitely use a service mesh. If you don't have these needs, the additional cost of a service mesh may be too burdensome. This was a lot of fun getting to speak at HacktivityConf. If you have questions, I'll be in the conference's Q&A channel in a minute, or reach out to me on Twitter at rob_rich, or grab these slides right now at robrich.org. Thanks.